Hello! So I thought it would be a fun exercise if I took 50 of the most commonly used drone mapping terms and defined them in this video, so that if you're just starting out with drone mapping, you can very much learn from this video. And it could also be drone inspections, in fact. This is either just terms that are commonly used in the industry, and hopefully they're useful to someone watching. Let's have a look. Hey everyone, I'm Varun from Radiometric, and we're going to go through 50 of the most commonly used words in drone mapping. So let's start with sensor. So sensor is just a term that we use to describe any camera that is airborne or essentially used as a payload with the drone. This could be a thermal camera, a visual camera, it could be a Lidar sensor. So it's just essentially the payload carried by the drone. Right, mechanical, global, shutter, or electronic rolling shutter. Now, these are just the different types of shutters that are available on the drone. And what you're able to do with them is that the global mechanical shutter allows you to capture all of the details in one shot. And that allows for better mapping generally, so to speak. Most of the new drones already have this sensor, have this type of shutter. So you don't really have to worry about whether or not you have that on your particular drone. Motion blur or M-blur. So motion blur or M-blur is essentially another term that's used essentially to describe the amount of ground smear or the amount of motion blur in your images. This is basically because the drone's flying too fast and actually can't take, the camera can't keep up with it. So that's just the term used to describe that particular phenomenon. Right, the next one's really important, and that's GSD. So GSD stands for ground sampling distance. So that's essentially the amount of ground covered by the pixels in the image. So if you imagine two different pixels in every image, the amount of ground between each of those two pixels is actually the ground sampling distance. And lower the ground sampling distance, higher is the resolution of the data, and higher the ground sampling distance, lower is the resolution of the data. So really important to keep in mind, GSD. Right, so the next one is overlap. So overlap, when we talk about that, that essentially means the amount of overlap or the amount of common area between two images in a flight. Sometimes we refer to this to as front lap and side lap, and that basically means when you're mapping an area, how much of every two photos have a common region between them. And this common region essentially is used for photogrammetry, which we're going to come to later on, to be able to create 2D maps and 3D models. So overlap, really important as well. Focal length. Well, focal length is essentially nothing else but a property of the camera used by your drone. And that focal length essentially allows to or dictates how far can the drone's camera see in terms of its field of view. A larger focal length will be able to give you images that are highly detailed or sharper, but with a narrow field of view. And a shorter focal length will give you images that are more spread over an area, but are not as detailed. So focal length is just a property of the camera borne by the drone. Next is exposure. So exposure essentially is just the amount of light coming into your drone's camera, and that really dictates whether your images are going to be overexposed, too much light, or underexposed, too little light. So you want to be able to manipulate that to get the best results. Right, so the next one, GCP or ground control points. So ground control points, GCP is really important. So these are essentially just markers that are placed on the ground that are used to correct the inaccuracies in the drone's GPS. So the drone's GPS, generally speaking, is between 1 to 2 meters accurate. And if you want your map to be centimeter level accurate and not meter level accurate, you want to make sure you correct for that. The way you do that is by using GCPs, these markers on the ground, and recording their positions. I've got a whole video on GCP that you can go watch if you're interested in learn more, but it's essentially a method to improve the accuracy of your drone map or model. Right, so the next one is RTK or PPK. So RTK stands for real-time kinematics. This essentially is a method to correct the positions of the drone's GPS in real time, so as the drone flies. And what this requires is that you've got your remote controller connected to a smartphone app, and then that app essentially connects to either a network or a base station and allows for better GPS data or corrected GPS data to be included in the images that come out of the drone. Once again, this is an accuracy enhancing measure, just like GCPs. And you can not just do this in the real time, but also do it essentially in the post. And that method essentially is called PPK, which is post-processing kinematics. And what happens over there is that all of your drone, base station, or recording equipment record the data separately, and they're combined later on. So that's PPK. Oblique images. So oblique images essentially is the term that's used to describe images taken from the drone at an angle. Now, these images are really important, especially if you're doing any kind of work that involves buildings, facades, or built-up structures. Anytime you've got a built-up structure on a site, you want to make sure that you capture it not just from a top-down nadir point of view, but also from the side points of view, because the sides is what essentially allows you to reconstruct a 3D model in the highest quality possible. So oblique images, really important as well. Terrain follow. So terrain follow essentially is a name that's given to a flight where the drone follows the curvature of the surface or curvature of the ground. So if you've got uneven ground that you're mapping, you want to make sure that you follow that ground whilst you're capturing images. And the reason for that is you want to make sure that your GSD or ground sampling distance is very much uniform across that uneven plane, and the overlap between images is also not affected. So terrain follow, really important to be able to get GSD and overlap right, which we defined earlier. Right, so the next one is ground offset. So ground offset is essentially when you've got a building that you're mapping, and let's say you take off not from the ground, but from the roof. And what happens is you're essentially, well, in fact, you could take it from the ground as well. What happens is when you're flying, you might have accounted for the overlap with respect to the ground, but not with respect to the roof. So this one's a bit nuanced, and we've got a whole different guide and video on it. But basically, the overlap needs to be calculated by taking the offset from the ground into account, and that offset is called the ground offset. So the overlap calculations are done in the plane of the roof and not in the plane of the ground. So better check that one out in a different video that we've made. So the next one is waypoints. So waypoints is just the term that is given to the set of points that are uploaded to the drone when it flies automatically and flies through a flight path. So just a set of points that it will go through to be able to capture data is called waypoints. These are the same waypoints that are used whether it's a mapping flight or 3D modeling flight or a facade flight. It's just a set of points uploaded to the drone. Right, next one, smart controller. So smart controller essentially is the term given to new controllers that have come out from DJI and also from some other manufacturers, but predominantly DJI, that allow you to essentially have a built-in screen, and you're able to actually get apps like Hammer Missions on those screens to be able to essentially fly your drone and capture high-quality data. The next one on the list is KML files. So KML files are essentially files that are in a proprietary format from Google, and these are really important if you want to overlay anything on top of Google Earth or Google Maps. But also, if you want to be able to import your flight boundaries from a third-party program or from a client or stakeholder, you can essentially do that in the KML format and essentially start your flight planning using the KML file. So really important as well. The next one on the list is Lidar. So Lidar is essentially, it's just a type of sensor. It's a laser scanning sensor. So you're essentially using beams of light to be able to create cloud of points and create essentially a 3D representation of the area. So generally used for very specific applications in engineering and surveying, but Lidar is a type of sensor that you can put on the drone to be able to capture data. Geotag. So geotag is essentially the term given to essentially images that have geo coordinates in them. So essentially any image that's taken by the drone has the location data embedded in them. And so they're called geotag images. The next one is roll, pitch, yaw. So all pilots are going to love this. So this is basically just the three terms that are given to the different axes of the drone. So a drone can roll, which is essentially this way. It can yaw, which is essentially that way. And it can pitch, which is essentially that way. So the three different axes on which the drone can essentially turn or rotate is the roll, pitch, yaw. And then you've got calibration. So calibration, just a term given to making sure that all the onboard components of the drone are working correctly and essentially have been leveled, so to speak, with respect to known criteria and are working correctly to the environment and the known criteria. So that will be calibration. Photogrammetry. So photogrammetry is the term given to the science of being able to measure and reconstruct from images. So it's essentially the term that we use to be able to describe creating these maps and models. It's the technique that is used to create 2D maps, 3D models using drone images. So anytime you see drone photogrammetry, you should mentally replace that with 2D maps and 3D models, because that's where generally it's used in the drone world. Digital twin. So digital twin is a very difficult thing to define because different people have different definitions. But from my perspective, it's essentially a living, breathing replica of the physical world asset. So if you imagine there's a building or a wind turbine or a solar panel, and you want to have a digital version of that, it's essentially referred to as digital twin. You can also think of it as a series of 3D models that you create and also have other information overlaid on top of that. That would be a digital twin, and it's becoming quite important in the construction and telecoms industries. So one to check out further. Annotation. So annotation is the word that we use to describe any kind of markup or any kind of note, comment, or essentially a markup that is added to the 2D map or the 3D model that's created from the drone. So it's just a way to be able to record information, to be able to convey information in a more visual and meaningful way. Alignment or aligned images. So when you create a 2D map or a 3D model, you use the process of photogrammetry, which was what we described earlier. And one of the steps in photogrammetry is aligning of the images. And what this means is that when you take images from the drone from multiple different angles, you want to make sure that those images actually align with each other. They agree where that 3D object actually is, or where that 2D object really is. So that is basically alignment. The step is called alignment. So you want to make sure that if you take 1,000 images, all 1,000 of those align, or as high a percentage of those images align, because that creates a better quality model. A 2D map, well, a 2D map is basically just a map, but it's 2D, so it doesn't really have 3D information. It can generally be overlaid on base maps like Google Maps, and it conveys 2D information, allows you to get a bird's eye view on a particular site or area. A 3D model, so a 3D model, technically speaking, is essentially a set of triangles that are put together that create this sort of 3D reconstruction of the real world. And these are essentially, can be overlaid on top of Google Earth or similar, but they are generally sort of just made available inside the software for you to be able to play around and get a feel for what the site looks like. And these are typically dimensionally accurate, so they can be used for measurements and many other purposes. Right, the next one is Topo, Orthomosaic, Orthophoto. So all of these are actually referring to the same thing, which is 2D maps. So the 2D maps that you can make with drones are essentially referred to as topos, orthomosaics, or orthophotos. They all mean very much the same thing. And that's just a way of putting all these images together into a 2D map and making sure they're scale corrected and they can be used for measurements and they're dimensionally accurate. Right, the next one we've got on the list is digital elevation model. So a digital elevation model is essentially really just a file that has elevation profile for the particular area that's been mapped. So if you imagine a 2D map has been created for an area using drones, the elevation profile for every single point on that site is essentially an elevation model. And they're also sometimes referred to as digital terrain models, with the difference between the digital terrain model and digital elevation model being that one of them includes the structures on top of the site and the other one doesn't. So DEM and DTM are these two terms that are also worth keeping in mind. The next one we've got is radiometric. So radiometric is basically a term used to describe thermal images that have temperature data encoded in them. So some cameras are radiometric in nature. Of course, I'm talking about thermal cameras over here. Some cameras are radiometric, which means that they can store thermal information or temperature information, and therefore they can be used for temperature analysis. Whereas other cameras actually don't have this property, and therefore they can't be used for temperature analysis, even though they might be okay to use in a search and rescue context. So radiometric is another important term to keep in mind. The next one we've got on the list is relative versus absolute accuracy. So accuracy in the drone world comes in two different forms. Relative accuracy basically means that the map or model that you've created is internally consistent and all the measurements inside the map or model are accurate relative to each other. However, absolute accuracy means that whatever map or model you've created, how is it geo-positioned or geo-referenced in terms of the base reality, and how well does it align with the base reality is what is referred to as by absolute accuracy. We made a whole video on this, so if you want to go check out accuracies, feel free to do so. The next one on the list is 2D measurements. So 2D measurements generally refers to measurements that you'd make on a 2D map. This could be roof measurements. This could also be measurements on a construction site. Any measurement on a 2D map would be 2D measurements, and likewise a 3D measurement would be things like height measurements or volume measurements. The next term we've got is earthworks. So earthworks essentially refers to a particular stage in the construction cycle of a project where ground is being moved around. And in this particular stage of construction, drones can be really helpful because they can be used to capture volumetrics and tonnage of different materials that are being moved across on the site. And in fact, volumetrics and tonnage are the next terms that I was going to define. These are essentially terms given to describe the amount of aggregates that are on site, the amounts of materials that are on site, and also the total amount of mass that these particular aggregates represent. The next one we've got is progress tracking. So progress tracking is another construction-related word that is used to essentially describe using the drone to capture the same site over and over again, and to ensure that you can catch all the changes that are happening on the site and be able to actually take the right actions when those changes happen. So progress tracking refers to that particular side of things. Now we've got azimuth. Azimuth essentially is a term given to the angle on certain structures. Typically it's used in the drone context when it comes to cell tower inspections, because companies want to understand the azimuth angle of the antenna on these cell towers with respect to the due north, and azimuth is a name given to describe that. The next one we've got is coordinate reference system. So coordinate reference system is basically, as the name implies, a system that is used to describe what is the coordinate system, what reference system is the coordinate system following. So depending on the geography you're in, there might be lots of different coordinate systems, lots of different ways to describe the X, Y, Z positions of the drone, map, or model. And so what particular system is being used is referred to as the coordinate reference system. So for example, in the UK, a coordinate reference system that is commonly used is the British National Grid. So yeah, that's just basically the reference system. Point cloud. So point cloud is essentially just a set of points. So this is essentially a set of points that can be created during the process of photogrammetry. So during the process of creating a 3D model from the images, but can also be referred to as when you are doing laser scanning or any kind of scanning that involves Lidar, you also get a point cloud output at the end of it. It's just a set of points that is accurate in terms of spatially accurate with respect to each other. Textured mesh. So textured mesh is a type of deliverable that gets created. Essentially, when you create 3D models using drone images, one of the outputs is a textured mesh. And a textured mesh essentially is just a set of triangles that has been put together that has the right texture on it so that the surface looks as accurate as possible with respect to base reality. One that I have made another video on, so feel free to go check that out if you're interested in learning more about textured meshes. Raster files. So raster files is essentially a term that is used to describe a file that has essentially a grid of pixels, and each pixel is representing some meaningful information. So meaningful information could be, for example, elevation profile. So DEMs, or digital elevation models, typically follow the raster format, but you also have raster formats for other types of files, other types of data. So it's just a file format that you need to be aware of. Inspection reports. So inspection reports are essentially just reports that are required to maintain or deliver the condition of an asset. So you might be surveying a building or a solar panel or a wind turbine or a cell tower. You might want to have the inspection report as a deliverable, which is just a PDF file that goes through all the images with all the annotations and all the issues that were found in that particular site or assets. Sitemap. Sitemap's just a word used to describe a 2D map or a bird's eye view map that was created using the drone, typically for construction and mining projects. Cut and fill maps. So cut and fill maps are essentially maps that describe the amount of cut and fill volume on a particular construction site. So if you think about aggregates or materials, there is an amount of volume above the surface above the ground, and that's called the cut volume. And fill volume is the amount of volume that is below the surface. Again, I've made a whole video on cut and fill, so feel free to go check that out. Overlays. So overlays, for example, .dxf or .dwg, these are just names given to things that you add on top of the map to be able to create essentially a comparison between your design files and the drone data. So overlaying design files on top of drone data is done through the method of overlays. Worth knowing as well. CAD, so computer-aided design CAD. So a lot of people know that CAD's used in engineering environments. So if you've got something that is working with an architect, engineer, or contractor, you're probably going to come across CAD and also BIM. BIM stands for Building Information Modeling. And these are just essentially programs that are living and breathing in that industry. And so because drone data has started integrating, interfacing with these programs and protocols, it's important to be aware of this particular industry. Then we've got .dxf. So .dxf is essentially another format that is used. It actually stands for Drawing Exchange Format, and it essentially is used to be able to overlay data from the CAD or BIM world into the drone world and backwards. So essentially, it's an interchangeable format to be able to share design files. Then we've got the .tiff or Geotiff files, and these are files that are used to essentially have your 2D map exported in the form of an image that is both geolocated and georeferenced, so that it can also interact with GIS systems and allow for better third-party integration. Then we've got .obj. So .obj is a file format that comes out of your 3D models. It stands for Wavefront OBJ file, and essentially this file can be opened by lots of different 3D model viewers and can be maintained on file if required. And then finally, we've got the .las format, which is the laser file, and this format essentially comes from the laser scanning world, but essentially any 3D model that is created with a drone can also be exported into a .las format so that it can integrate with the laser scanning workflows and more. Right, I whizzed through that 50 list pretty quickly. I understand that this is a very, very quick, high-level overview in terms of some of the terms that are being used in the drone mapping world. I thought it'd be fun to just go through them and have a line or two on each one of them. Hopefully, we were able to surface some terms that you may not have come across before, and maybe that represents some opportunities for you to look into. In any case, hopefully this video was interesting. If you found it interesting, do give us a like, and if you think that other people might benefit from watching the video, please do feel free to share. We'll see you in the next video series of Knowledge Hub.